कैसे हैं आप लोग? Once again, very good evening to all of you and welcome back to the sessions. Myself Harsh Priyam, a master teacher of mathematics at Vedantu, taking your today's session on coordinate geometry. So I'm pretty sure that all of the class 9 students must be here and even the younger classes might also be there. So very good evening to all of you guys. Today we are going to discuss about coordinate geometry. And what is this coordinate geometry and how it is going to help us? We'll be seeing all of them. And let me tell you, this is a very important chapter. Why I'm telling this? Because this chapter is surely going to come in class 10th also, as it is, with more information. So in this class 9th, right now, this is a basic building block. So please have a very good look at this chapter so that you can do all of the required parts in class 10th, because it is very important. Apart from that, let me tell you that this chapter is pretty easy, very easy. Probably we would be completing this chapter in only 2 sessions or maybe 3. I guess only in 2 sessions. So this is a very easy chapter, and in NCERT it is given very little and less. So I've just taken few extra concepts also for you guys. So let's see what is there. So we are going to discuss about coordinate geometry. Let me have my pen. In this coordinate geometry, we will be talking about introduction to coordinate geometry, means what is coordinate geometry, how we use the graphs, how is everything going on, what is Cartesian system and everything. So this is the basic introduction we'll be doing. Apart from that, this Cartesian system we'll be doing in today's session itself. What is Cartesian system and how is it has been developed and what are its different parameters. Then in the next session, means and the next session which is going to come, we'll be doing the plotting of a point in the plane and some other miscellaneous questions also. So we'll be doing these 2 topics in today's session. Let's start and see. So before starting, let me give you a brief history about this coordinate geometry. There was a French mathematician, René Descartes, French mathematician, who wrote a book, La Géométrique, in 1637 in French, surely. And thereafter, in that book, Descartes used algebra for studying the geometry. Okay, it was a pretty new thing at that time, because using algebra for studying geometry was a very new thing. And what algebra he applied? So he basically put all the points a name in the name format of algebra, and he started calculating the distance, naming the figures using algebra. So all this thing was named as coordinate geometry, and on his name only, the Cartesian system was named. Cartesian, on the name of Descartes. So Cartesian is taken from here. So Cartesian coordinates, whatever we talk about, x-axis, y-axis, this is all taken on the taken from his name, Descartes, in his honor. So let's start. This is a brief history about this coordinate geometry and who is the mathematician responsible behind it. So it is René Descartes. So let me tell you what is this coordinate geometry and how we are going to enter into this. Do you know number line? Have you heard about number line? I guess you all would have. So number line is a simple straight line on which 0 is there, 1, 2, 3, 4 and so on numbers are here. And in the similar fashion, here we have -1, -2, -3 and so on, isn't it? So this is the number line which we have studied already. Now you just imagine that we have the same number line. I'm just rotating this number line to 90 degree. Means I want a vertical number line. So if I just rotate this 0 is going to be here only. Now it will be looking like this. This 1 will go to this part. So it will be 1, 2, 3, isn't it? And so on. I have just used the same number line, but it is vertical right now. And surely this -1 will come to this side. So it will become -1. -2, -3 and so on. Now you tell me, if I combine these 2 lines together, will I get this type of figure? 0, both of the zeros will be coinciding at one point. So this is 0 and then 1, 2, 3, 4 and here also 1, 2, 3, 4, -1, -2, -3, -4 and here also -1, -2, -3 and -4. In this manner it will go on, isn't it? 1, 2, 3, 4. Now, this is the system which is called as Cartesian system. Basically, we call this horizontal line as our x-axis and this is as y-axis. Now someone can have this question that, sir, why this is x-axis, why this is y-axis, can we name it something else? See, you can name it anything. You can name it a-axis and b-axis also. That does not make a difference. But you know what? We have just defined few terms as a convention. Say for example, if you walk on the road, you are always told that you should walk left side on the road. Now, if you will ask me that, sir, is there any health benefit with that? I'll say no. So, is there any reason behind it? I'll say no. Because just we have to make a rule and regulation. That's why we have made it. We could have made it walking down right side of the street. That could have also been fine. In America, right side driving is there. So, what I'm trying to tell you, that few notations, few conventions are made and that we have to follow. There is no such rule. So that is why this x-axis and y-axis have been made without any such explanation that why they are naming it as x-axis or y-axis. So it's just a convention which we will also follow. Now, how is this x-axis and y-axis is going to help? I'll tell you. Okay, so I guess you would have understood that what is x-axis and y-axis. It's just simple. The number line, horizontal number line is called as x-axis, and similarly the vertical number line is called as y-axis. Now, say for example, I have taken this kind of sheet, means a boxed kind of sheet. Now you just assume one thing, and that assumption is that, say for example, here I am representing, this are the columns and these are the rows. First row, second row, third row, fifth row. And just imagine that here I have this box. So I can say this box is in fifth column and in third row. Do you understand this? This box is placed in fifth column and third row. So fifth column and third row. Now see, if you have to tell this to a person, if you have to tell this information to a person, you can say column 5, row 3. If you want to write it more easily, you can write it 5,3, and you will say that person that always assume that column is written first and then row, isn't it? Now, if you want, you can even make it row first and column then second, row comma column 3, 5, isn't it? But again, we have made that convention. If you remember that we have assumed this as x-axis, horizontal one, and the vertical one as y-axis. So always we will write the x-axis first, means the column first column and then row. So we always write this as 5,3, not 3,5, isn't it? And so 5,3 would be my notation. This is standard notation. Now let me tell you one very important thing, that do you think that now if I write the same point 5,3 as 3,5, they will be same? I don't think so. Because once if I made the notation as x, y, and then if I write 3,5, then the person in front of me, he will understand that x is 3 means number of column is 3 and y is 5 means number of row is 5. So he will come to this location, and this location are not same. They are different, isn't it? So 3,5 and 5,3 are not the same thing once we have explained this notation. So always remember that 3,5 and 5,3 cannot be written as same. Okay. And always remember one more thing, that x will be written first and then y, means horizontal coordinate will be written first and then vertical coordinate. Okay. So let's do some interesting fun fact loving thing. How will you describe the position of the table lamp on your study table? Now, I'm just assuming that this is your study table. Okay. This is something interesting. Okay, let's do it. So this is your study table and somewhere here your lamp is placed. Now, how are you going to locate this? Because on study table, there is no scale or nothing like that. So you can form one scale of your own. You can tell this that this is vertical, so y-axis, and this line is horizontal, so you just assume it as x-axis, and then mark these points using a scale 1, 2, 3, 4, 5, 6, 7, 8. So at 8th position you are getting this dot. Okay. Similarly here 1, 2, 3, 4, 5, 6, 7, 8. So say for example here 6. So at the 6th position you are getting this dot. So here you are able to find it out that on x-axis you got a point that is 8, and on y-axis, on vertical axis, you got a point that is 6. And if you want to name this point, you can name it as 8 comma 6. So this is how you can describe the location of a table lamp on your table, means using the coordinate geometry, and its location would be simply 8 comma 6 or whatever coordinates you get it. So by using the coordinate geometry method, using the axes, x-axis and y-axis, you would be able to find the position of a table lamp. Okay. Now, can you tell me that what is a application of this Cartesian coordinate geometry in real life? Means in real life, I'm sure that you would not use to find the location of a table lamp on a table using coordinate geometry. You will say me, sir, why would I even use it? I know there is table lamp. So I'll just tell you one practical application, and that's a very interesting application. Do you know GPS? Or you would have, if you don't know GPS, you would have known about Google Maps. I guess everyone use it, isn't it? Google Maps. Every mobile has this Google Maps facility. Now, what is this Google Maps? Google Maps is basically an application in your mobile, Android mobile. That application says that, say for example, if you are here and if you have to go here, then what is the best route or possible method with which you can go here? Say for example, if it's a direct road, you can very easily travel from this point to this point. And Google Maps tells you that location. Now, can you tell me that how Google Maps calculate that? If you are at this position, you are at this position. Don't you think that it looks like a coordinate geometry? Say for example, Google Maps will also use this coordinate geometry system, x-axis and y-axis. It will locate your position that you are first at x comma y coordinate and someone else is x2 comma y2 coordinate, and you have to move from this point to this point. So how much time, how much distance is it going to be there? So let me tell you, although it's not only coordinate geometry, there are multiple other factors also, but let me tell you, the basic building block or the starting point for drawing any type of maps is this Cartesian coordinate system. Even your maps which you study, all those maps are drawn using this coordinate system only. So the real life application for this coordinate geometry is maps. Okay, let's move on. So this is how it will be looking like. This is x-axis, this is y-axis, and here it is the positive x-axis 1 2 3 4, and here it is the negative -1 -2 -3 4, and similarly for the y, positive y-axis and the negative y-axis. Now, do you know that all the points which we write, they are in the form of x comma y, isn't it? So say for example, if I'm writing this point particular, so I can write or this point, I can write this point as on x I am getting this as 3 and on y I am getting this as 2. So 3 comma 2. That's fantastic. Now, so you would be able to understand that here x is positive and y is positive. Both the coordinates are positive. Okay, that's fantastic. So x is positive, y is positive. Now if I just move this point to this part, so I would be able to write this point as -3 comma 2, because x is always written as first and y is second. So x here is not 3 but it is -3. So now can I write it this like this, that here the first coordinate is negative and the second coordinate is positive, minus plus. Similarly, if I come down to this portion, I would be able to figure it out that this point is -3 and comma -2, isn't it? So here also it's x comma y, and here at this time both the coordinates are negative, minus minus, x comma y. And similarly, if I go to this part, I will be getting 3 as plus but -2 as negative. So I have x comma y again, and that says plus comma minus, isn't it? Now you would be able to understand that in every situation, every portion of this Cartesian system, I am getting a different type of sign, means different type of x and different type of y. And that is why we have divided this Cartesian plane. See, this whole thing is called as plane. Plane is any two-dimensional surface. So this Cartesian plane is divided into 4 types, or 4 what you can say, 4 planes. So 4 divisions are there. And you know, 4 divisions, since it is 4 division, so out of this one plane, it has been divided into 4 parts. So every 1/4 part is called as quadrant. You all must be knowing that 1/4 is called quadrant. So this is called as first quadrant because both being positive. So this is the first quadrant. And from here we will walk anti-clockwise direction, isn't it? Anti-clockwise direction. So this is my second quadrant. Similarly, anti-clockwise, so from here to here, this is my third quadrant. And then this is my fourth quadrant. So this is my fourth quadrant. So in this fashion, we have divided this whole plane system into 4 quadrants. First quadrant, both being positive. Second quadrant, minus plus. Third quadrant, both negative. And fourth quadrant, plus minus. Okay. So I guess you would be even able to understand that, just say for example, if I have given you a point 4 comma minus 5. Can you tell me in which quadrant this point would be lying? This is plus minus. So plus minus lies always in the fourth quadrant. So this point would be in a fourth quadrant system where x is 4 and y is minus 5. So even if I'll tell you to locate this point, you will simply move on the x-axis to 4 units and on y-axis to 5 units. So here you will get your point, isn't it? So this is how it works. This is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. This what I was talking about. This is plus comma plus, minus comma plus, minus comma minus, and this is plus comma minus, isn't it? Okay. So if you have understood this, let's move on. Let me tell you, we have just now seen that, say for example, if I have to get the distance of any point, what I do, say for example, this is 3 comma 2. So what I was doing, I was just drawing a perpendicular line. This perpendicular line on x-axis. See, this perpendicular line on x-axis. This is 0.3. And if I talk about this, this is 2. Okay, because y is 2. So on y-axis I'll get 2, and on x-axis I'll get 3. That's fine. Now, can you tell me that if this is 2, so surely this is 2 unit length, this whole line. And if this is 2 unit length, this is also 2 unit length. So from what I want to tell you, that from this point, if I draw a perpendicular on x-axis, so the length of this perpendicular is the y coordinate. Vice versa means, from this point, if I draw a perpendicular to x-axis, the distance which I will get, the length, the measurement, that measurement is the value of y coordinate. Similarly, from this point, if I draw a perpendicular to y-axis, the measurement which I get is equal to the x coordinate. So it is written here, the x coordinate of a point is its perpendicular distance from the y-axis. Perpendicular distance from the y-axis is the x coordinate, isn't it? So vice versa it will go on. If I have any coordinate system, then this distance is going to be y-axis coordinates, and this distance on y-axis is going to be the x coordinate. Okay. So similar thing is written here also for y also. And let me tell you one more important thing, that say for example, if I do x comma y or 2 comma 3, anything like this, always remember that x, the first coordinate, is also said with a name that is called abscissa. Please always remember this, because most of the time questions are asked from abscissa, that what is abscissa, or tell me the abscissa of this point. So abscissa is always the first point, that is x coordinate. And similarly for y coordinate, we have a different name that is called ordinate. Only ordinate. It's not coordinate. It's ordinate. O-R-D-I-N-A-T-E. Ordinate. So this is y coordinate. Y coordinate. And this is x. Abscissa is called as x coordinate. So I guess you would have been able to understand this. If you have understood, let's move on and see some examples. Very interesting examples. Okay. So can you tell me the point, means x comma y coordinates of P? Can you tell me? So for P, I can see on x axis I am having 4. So I'll write 4 for x. And on y axis I am having 3. So I'll write 3. And the coordinates for P is 4 comma 3, isn't it? Similarly, if I talk about Q, first talk about Q. So if I talk about Q, you would be able to understand that on x axis the coordinate is -6. So this is -6 first, and on y axis it is -2. So -6 comma -2 we got. And see here, P is 4 comma 3 and Q is -6 comma -2, isn't it? So let me tell you, this is how we find the coordinates of any point. Let's move on and see something more. Now, again, one more example. Here also, we have to find the coordinates of these different points. So what are these different points? The first point, this B. So let's find the coordinates 4 and 3. So I'll write here 4, 3. If I come to this point, M, X coordinate is -3. So this is -3 and Y coordinate is 4. -3, 4. If I talk about this point L, X is -5 and Y is -4. So -5, -4, and for S, if I talk about, I'll be getting this 3 and this is -4. So this is 3, -4. Always take the X point, X coordinate and then Y coordinate. And I guess you would be able to now write down the coordinates for B. We have find out 4, 3. Okay. Sorry, they are asking about the abscissa and ordinate. So abscissa is 4 and ordinate is 3. Similarly, coordinate, so now the coordinate would be 4, 3. X coordinate, Y coordinate for point M. So you would be able to see -3, 4 and so on. You will be able to answer all these questions, isn't it? So now I guess you would have understood this very easily. If you have understood, that's really fantastic. And that was all from my side for today's session. I'll be seeing you guys again in the next session with some more questions and more interesting facts. Till then, take care and do comment what you like and what did you not like. I'll be improving on that every day, every moment. So see you guys in the next session. Till then, bye bye and take care. Bye.